All right, let's discuss now the idea of coordinate conversion. We want to be able to go from the Cartesian coordinate system, the rectangular coordinates, to polar and polar back as we need to, however it pleases us. So if I let the polar axis coincide with the positive x-axis, which I did earlier, and the pole with the origin, then for r positive we have basic trig functions that will give us some relationships we can work with. Now, here's the idea. For r positive, I'm going to stay in the first quadrant here. So here's r, here's theta. Now, clearly this distance here is y, and this distance here is x. So I can now relate the angle theta and r with x and y. Cosine of theta is equal to x over r. That would then imply that x must be equal to r cosine theta. Sine of theta is equal to y over r. That would then of course imply that y must be equal to r times sine theta. Now, these basic trig functions relates the idea of xy from the rectangular coordinates to the polar coordinates. So let's take a look at a quick example. I want to convert to rectangular coordinates -1, 5 pi over 4. Remember, this is r and this is theta. And what we just did with some basic trig definitions, we said that x is equal to r cosine theta and y is equal to r sine theta. So in this case, this could be -1 times cosine of 5 pi over 4, and y is going to be -1 times sine of 5 pi over 4. Well, where's 5 pi over 4? Well, let's see. 4 goes into 5 once, so I know that's a full pi. And then there's a quarter pi left over. So this is 5 pi over 4. So I'm in the third quadrant, so I know cosine is going to be negative. So this is going to be a -1 times a -√2/2. And likewise for sine, sine is also negative in this quadrant. So I'm going to have a -1 again times a -√2/2. So x equals √2/2 and y equals √2/2. Let's draw this real quickly. So here's my polar axes. I go to 5 pi over 4, which is over here. But my distance is -1, so I'll go in the opposite direction. A distance of r equals 1. Okay, it's -1, but it's the opposite direction of what I'm pointing. And here's my point, -1, 5 pi over 4 in polar coordinates. Now if I look at this, what I want to do, so I want to find the x and the y coordinate. And to do that, you can just use some basic trig, and as soon as you do, you work that out, you're going to see that these coordinates are in fact √2/2 and √2/2. So here's my polar coordinates describing this point. Here's my rectangular coordinates describing that same point. Okay, converting from rectangular to polar. So now I have 3, -1. So let's just draw this real quick in rectangular. X is 3, 1, 2, 3. Y is -1. Here's -1. So I have the point right here. Now, I want to take this from rectangular to polar from 0 to 2 pi. So I need to convert this, and the way I'm going to do this, I'm going to use the relationship r equals the square root of x squared plus y squared. We know that to be true. So in this case, this could be the square root of 3 squared plus negative 1 squared, which equals the square root of 10. So I know that my radius is going to be a square root of 10. Then from there, I also know, because this is x and this is y, I also know that tangent of theta will be a negative 1/3. That means that arctan of theta equals arctan of negative 1/3. Well, that's saying that theta equals arctan of negative 1/3. So this is not a common angle. So if we put this in a calculator or let Maple work on it, we find that this is a negative 0.3218. So if this is 0, a negative angle will come counterclockwise. Here's my angle theta. And the distance is going to be root 10. That's my radius. So my polar coordinates representing this, 3, negative 1, is a negative root 10. Root 10 is the radius. And then the angle is arctan. I think I'll go write this as, arctan of negative 1/3, which we know is this angle. But remember we said between 0 and 2 pi. Well, if I add pi to this, I come up here. If I use a negative radius, then I'll be back at the same point. So I have a negative root 10 arctan of negative 1/3 plus pi. That brings me here. And if I add 2 pi to this, I will come all the way around. And I'm still between 0 and 2 pi, because this is 0. And clear around would bring me back to 2 pi. So I can write this again as this time root 10 arctan of negative 1/3 plus 2 pi. So what I've actually done is I've identified this point 3 ways. This first way I calculated, but actually is not part of the solution, because this angle arctan of negative 1/3 is a negative angle, and it is not between 0 and 2 pi. But based on this, I added pi to it, which brought me into this interval 0 to 2 pi. Added another pi that kept me within the interval 0 to 2 pi. So my solution to this is actually these 2 representations. Okay, the point in the polar plane satisfying r equals k is a circle of radius k, and the point satisfying theta equals k is a line. So as an example, theta equals pi over 3. Well, if theta is pi over 3, then it's always pi over 3. So for r positive, I'll be in this direction. For r negative, I'll be going in this direction. So it's this line. For r equals 3, 1, 2, 3, it's a circle. Pretend for a moment like that's actually a circle. Because the radius stays constant at 3, and as it ranges from 0 to 2 pi, it goes through all the angles, all values of theta. It's just a circle at 3, again and again and again. Okay, let's take a look at maple and play with this for just a minute and see what we get. And I'm going to plot, I'm going to start off with plots. I need that command first with maple, because what that's going to do, that's going to bring up a bunch of plot commands that I need, and actually the only one that I really need is right here. Where is it? Right there. Polar plot. That's the only command that I need. So now I'm going to do polar plot. And then R is 3, and theta equals 0 to 2 pi. And there's my circle. You can see the red out here. That's the circle. I'm going to make it a little bit thicker, just to make sure we can see it okay. There, good and thick. You can see here, there's 1, 2, and 3, so the radius is 3, and it's going all around circles.